question 3 of the acids and bases worksheet. This one I took from the Mpumalanga paper 2, higher grade, November 2000. I liked that year, apparently. So, they say consider the following 2 equations, and what we've got here is this first equation is the ionization of hydrochloric acid, and the second one is also it's also an ionization reaction, but that's of ammonia. This is an acid, this is a base. The fact that they called it A and B really is actually irrelevant. Then they say which chemical substance above acts as both as an amphilite. So in other words, there's a substance that's in both of these, and there's only one thing that's in both actually, that can act as either an acid or a base. We all know this. This shouldn't be hard. It's got to be the H2O. So which one is it? H2O, or you can tell me water. Okay. How do I know it's the amphilite? In reaction A, it acts, it acts as a base, and I'm hoping you can read this. In reaction B, it acts as an acid. That was your theory question. Now they ask a nice question. This is why I actually chose this question for this. In which solution A or B, described by OD, will conduct electric current best? They are asking you which one is stronger. Remember, it's not about concentration. Strong acids and bases conduct electric current really well. Weak acids and bases don't. You have a strong acid and a weak base. You are expected to know that. HCl is my strong acid. My answer is A. Why? HCl is a strong acid which ionizes completely, alright. NH3 is a weak base which ionizes only slightly. Current conducts best when, I'm just adding this in so you really get what we're going, when there are a lot of ions. Okay? That's not so bad. We like that. 3.1 done. 3.2. Now this is a nice question because we gave you these. Now when we do this, we expect you to know methyl orange. Here they've given you methyl red, which is why we gave the table. So it says during the titration it is found that 25 centimeters cubed of sodium carbonate with a concentration of 2 times 10 to the minus 4 neutralizes, so there's going to be nothing left over, 40 centimeters cubed of sulfuric acid according to the following reaction. So we've got H2SO4 plus NaOH gives me Na2H2O CO2. They don't tell us whether it's balanced or not, so we're going to have a quick check. Yes, it is, so we're all happy. Then the following table of indicators was supplied, and we've got methyl red, bromol, thionyl blue, etc. Then they ask you which indicator would be appropriate for the titration and explain your answer. So what have we got? We've got a weak base with a strong acid. We're going to end up with an acidic salt. Okay? We're gonna end up with an acidic salt. What does that mean for me? The pH range that we're looking for must be below 7. Has to be methyl red. Okay? How do we explain that? Because that's obviously the next thing. So, 3.2, we've decided we need methyl red. If they didn't give this, you would have said methyl orange. Okay? Explanation. H2SO4 is a strong acid. Na2CO3 is a weak base. The salt formed, okay, the salt formed will be acidic in nature. It will hydrolyze, react with water, hydrolyze. Let's just say it will undergo hydrolysis, because right now I can't think of how to spell hydrolyze. It will undergo hydrolysis to form H3O plus ions. Thus, the final pH will be less than 7. Okay, so that's a lot to write down. Okay, but that's okay. So what are we looking for? I'm looking for, do you know that H2SO4 strong base, Na2CO3 weak base, we get an acidic salt, hydrolysis will happen, and the pH will be less than 7. Now, it was only worth 4 marks, so more than likely that'll be 1 mark. The acidic nature will be the second mark, and then the third one is the hydrolysis. Okay, straightforward. We're happy. We like this. Okay, we like this lots. We're very happy with this. So, now they say, calculate the concentration of the sulfuric acid solution. So let's look at what we were given. Well, we know how much base we've got. We know the concentration of the base, and they want the concentration of the sulfuric acid. This is so much easier than any of the others we've actually done today. Well, any of the other questions in the worksheet so far. I've done them. You might not have done them all at the same time. So, 3.2.2.1. Okay, so it's a long one. We have sodium, what did they give us? H2, I'm only going to write the first part of the equation, because that's actually the part that's important here. And Na2CO3. The nice thing is this was a 1-to-1 relationship. And because it's an acid-base reaction, the simplest way to do this, Na over Mb, Ca, Va, Cb, Vb, 1-to-1. I want the concentration of the acid. I know that I went and converted these to decimeters cubed. You don't have to, you can leave it in centimeters. They told me that this was 2 times 10 to the minus 4, and we used 0.025. We solve for Ca, and we get 1.25 times 10 to the minus 4 moles per decimeter cubed. We're like that, it's nice and straightforward. Then they say, calculate the pH of the sulfuric acid solution before the titration. So, we know that the concentration of the H2SO4, we've just calculated it, is 1,25 times 10 to the minus 4 moles per decimeter cubed. To calculate pH, I need the H3O plus concentration. We now recognize, alright, that in every H2SO4 molecule, there are two H3Os, two H's. That means the H3O plus concentration is twice as big as the H2SO4 concentration. That means it's 2 times 1,25 times 10 to the minus 4, which means it's going to give me 2,5, I was about to write 5, that's just ridiculous, minus 4 moles per decimeter cubed. We know pH is the negative log of the H3O plus concentration. That gives me the negative log of 2.5 times 10 to the minus 4. That means we get a pH of 3,6. The trick here is to remember that the H3O plus concentration is twice the H2SO4 because there are 2 hydrogens per H2SO4 molecule. So it's a 2-to-1 relationship. Great, we're done.